NEC Article 312.2 addresses damp, wet, or hazardous classified locations. Specifically, it states that in damp or wet locations, surface-type enclosures within the scope of this article shall be placed or equipped to prevent moisture or water from entering and accumulating within the cabinet or cutout box. Furthermore, these enclosures shall be mounted so there is at least a 6 mm, which is approximately 1/4 of an inch, airspace between the enclosure and the wall or the supporting surface. Enclosures installed in wet locations must be weatherproof. Crucially, for enclosures in wet locations, raceways or cables entering above the level of uninsulated live parts shall use fittings listed for wet locations. Now let's interpret this code. The key phrase is raceways or cables entering above the level of uninsulated live parts shall use fittings listed for wet locations. This means that if you have raceways or cables entering an enclosure at a point higher than where uninsulated, energized components are located, you must use fittings specifically designed and listed for wet locations. These fittings, such as Myers hubs or similar, are designed to prevent water from entering the enclosure through the conduit or cable entry point. To understand the application of this code, consider a situation where you have penetrations from the top of an electrical panel using standard lock nuts and bushings. These penetrations are between the panel, a disconnect, and a meter section. The question is whether you are required to use wet location fittings such as Myers hubs on these penetrations. The answer depends on whether these penetrations are considered to be above the level of uninsulated live parts. Typically, the connections between a panel, disconnect, and meter section do not involve uninsulated live parts. These connections are usually made with insulated conductors within approved raceways or connectors. Therefore, the code does not mandate the use of Myers hubs or other wet location fittings in this specific scenario. Myers hubs are designed to prevent water from entering an enclosure through conduit connections. They are essential in wet or hazardous locations where water ingress is a significant risk. However, in situations where the penetrations are not above uninsulated live parts and the connections are properly made with insulated conductors, the risk of water entering the enclosure through these connections is minimal. Firstly, consider the primary purpose of wet location fittings, which is to maintain the integrity of the electrical system by preventing water intrusion that could lead to short circuits, corrosion, and other electrical hazards. Secondly, the NEC provides specific requirements for different scenarios to ensure safety while also allowing for practical and cost-effective installations. Thirdly, understanding the specific requirements and their intended applications is crucial for compliance and safety. Now let's delve deeper into the technical aspects of electrical enclosures and fittings. Electrical enclosures are designed to protect electrical components from environmental factors such as water, dust, and physical damage. They are classified based on their ability to withstand these environmental conditions. NEMA, which stands for National Electrical Manufacturers Association, provides standards for enclosure types. For example, a NEMA 3R enclosure is designed for outdoor use and provides protection against rain, sleet, and snow. A NEMA 4 enclosure provides additional protection against hose-directed water and splashing water. When selecting an enclosure, it is important to consider the environment in which it will be installed and choose an enclosure that is appropriate for that environment. Electrical fittings are used to connect raceways, cables, and other electrical components to enclosures. They come in various types, each designed for a specific purpose. For example, conduit fittings are used to connect conduit to enclosures, while cable connectors are used to connect cables to enclosures. Wet location fittings are specifically designed to prevent water from entering an enclosure through the fitting. These fittings typically have features such as rubber gaskets or O-rings to create a watertight seal. Myers hubs are a type of wet location fitting that is commonly used to connect conduit to enclosures in wet locations. They consist of a threaded hub that screws into the enclosure and a gland nut that compresses a rubber bushing around the conduit to create a watertight seal. When installing electrical fittings, it is important to follow the manufacturer's instructions and the requirements of the NEC. This will help to ensure that the fittings are properly installed and will provide the intended level of protection. Now let's consider the specific requirements for electrical installations in wet locations. The NEC defines a wet location as an area where water or other liquids may drip, splash, or flow on or against electrical equipment. Examples of wet locations include car washes, docks, and areas subject to flooding. In wet locations, all electrical equipment must be listed for use in wet locations. This means that the equipment has been tested and found to be suitable for use in a wet environment. The NEC also requires that all raceways and cables entering enclosures in wet locations be sealed to prevent water from entering the enclosure. This can be accomplished by using wet location fittings or by sealing the raceways and cables with a waterproof sealant. Furthermore, the NEC requires that all electrical equipment in wet locations be installed in a manner that prevents water from accumulating on or in the equipment. This can be accomplished by mounting the equipment on a slope or by providing drainage holes. When working on electrical installations in wet locations, it is important to take extra precautions to protect yourself from electrical shock. Always wear rubber gloves and boots and make sure that the power is turned off before working on any electrical equipment. In summary, understanding the NEC requirements for electrical installations in wet locations is crucial for ensuring the safety and reliability of electrical systems. By following these requirements and using appropriate equipment and installation practices, you can minimize the risk of electrical hazards and ensure that your electrical installations will perform safely and reliably for many years to come. Now, let's talk more about uninsulated live parts. Uninsulated live parts are conductive components of an electrical system that are energized and not covered by insulation. Examples include exposed terminals, busbars, and bare conductors. These parts pose a significant risk of electric shock if contacted. The NEC mandates specific clearances and guarding requirements to protect people from accidental contact with uninsulated live parts. These requirements vary depending on the voltage level and the location of the equipment. For example, in accessible locations, uninsulated live parts operating at 50 volts or more must be guarded by enclosures, barriers, or other means to prevent accidental contact. The height and construction of these guards must comply with specific NEC requirements. In addition to physical guarding, the NEC also requires warning signs to be posted in areas where uninsulated live parts are present. These signs must clearly identify the hazard and provide instructions on how to avoid contact. When working on or near uninsulated live parts, it is essential to follow safe work practices. Firstly, always de-energize the equipment before working on it. Secondly, if de-energizing is not possible, use appropriate personal protective equipment such as rubber gloves, insulated tools, and arc flash protection. Thirdly, maintain a safe working distance from uninsulated live parts. Fourthly, never work alone when working on or near uninsulated live parts. Fifthly, be aware of your surroundings and avoid distractions. Sixthly, regularly inspect your tools and equipment to ensure they are in good working condition. Seventhly, report any unsafe conditions to your supervisor. Now let's discuss the importance of proper grounding. Grounding is the process of connecting electrical equipment and systems to the earth. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and clear ground faults. Grounding also helps to stabilize voltage and reduce electrical noise. The NEC specifies detailed requirements for grounding electrical systems. These requirements cover the size and type of grounding conductors, the methods of connecting grounding conductors to equipment and systems, and the location of grounding electrodes. There are two main types of grounding systems: equipment grounding and system grounding. Equipment grounding is the process of connecting the non-current carrying metal parts of electrical equipment to the grounding system. This helps to protect people from electric shock by providing a low impedance path for fault current to flow back to the source. System grounding is the process of connecting the neutral conductor of an electrical system to the grounding system. This helps to stabilize voltage and reduce electrical noise. When installing grounding systems, it is important to follow the NEC requirements and use appropriate materials and installation practices. This will help to ensure that the grounding system is effective in protecting people from electric shock and in providing a stable and reliable electrical system. Now let's shift our focus to conduit and raceway systems. Conduit and raceway systems are used to protect and route electrical conductors. They provide physical protection from damage and environmental protection from moisture, dust, and chemicals. The NEC specifies requirements for the types of conduit and raceway systems that can be used in different locations and applications. There are several types of conduit, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and rigid non-metallic conduit. Each type of conduit has its own advantages and disadvantages and is suitable for different applications. For example, rigid metal conduit is very strong and provides excellent protection from physical damage, but it is also heavy and expensive. Electrical metallic tubing is lightweight and easy to install, but it is not as strong as rigid metal conduit. When selecting a conduit system, it is important to consider the environment in which it will be installed, the type of conductors that will be routed through it, and the applicable NEC requirements. The NEC also specifies requirements for the installation of conduit and raceway systems. These requirements cover the methods of supporting conduit, the minimum bending radius for conduit, and the methods of connecting conduit to enclosures and fittings. It is important to follow these requirements to ensure that the conduit system is properly installed and will provide the intended level of protection. Now let's delve into the topic of electrical inspections. Electrical inspections are conducted to ensure that electrical installations comply with the NEC and other applicable codes and standards. Electrical inspectors are trained and certified to identify electrical hazards and to ensure that electrical installations are safe and reliable. Electrical inspections are typically required for new construction, renovations, and alterations to existing electrical systems. The inspection process typically involves a review of the electrical plans and specifications, a visual inspection of the electrical installation, and testing of the electrical system. The electrical inspector will look for things such as proper wiring methods, proper grounding, proper overcurrent protection, and compliance with the NEC clearance requirements. If the electrical installation does not comply with the applicable codes and standards, the electrical inspector will issue a notice of violation. The notice of violation will list the specific violations and provide instructions on how to correct them. It is important to correct any violations promptly and to schedule a re-inspection to ensure that the electrical installation is in compliance with the applicable codes and standards. Electrical inspections are an important part of ensuring the safety and reliability of electrical systems. By having electrical installations inspected, you can help to protect yourself and others from electrical hazards. Now let's discuss overcurrent protection. Overcurrent protection is the protection of electrical circuits and equipment from excessive current. Overcurrent can be caused by short circuits, overloads, or ground faults. Overcurrent can damage electrical equipment and can even cause fires. The NEC requires that all electrical circuits and equipment be protected by overcurrent protection devices. Overcurrent protection devices include circuit breakers, fuses, and other devices that are designed to interrupt the flow of current when it exceeds a predetermined level. Circuit breakers are electromechanical devices that automatically interrupt the flow of current when an overcurrent condition is detected. Fuses are single-use devices that interrupt the flow of current when an overcurrent condition is detected. When selecting overcurrent protection devices, it is important to choose devices that are properly rated for the circuit or equipment that they are protecting. The NEC provides detailed requirements for the selection and installation of overcurrent protection devices. It is important to follow these requirements to ensure that the overcurrent protection devices will provide the intended level of protection. Now let's discuss arc flash hazards. Arc flash is a dangerous electrical phenomenon that can occur when a short circuit or other electrical fault creates an arc of electrical energy. Arc flash can cause serious burns, blindness, and even death. The NEC requires that employers provide arc flash protection for employees who work on or near energized electrical equipment. Arc flash protection includes the use of personal protective equipment, such as arc-rated clothing, gloves, and face shields, as well as the implementation of safe work practices. The level of arc flash protection required depends on the potential arc flash hazard. The potential arc flash hazard can be determined by performing an arc flash hazard analysis. An arc flash hazard analysis is a study that calculates the potential arc flash energy at a given location. The results of the arc flash hazard analysis are used to determine the appropriate level of arc flash protection. When working on or near energized electrical equipment, it is important to follow safe work practices and to use the appropriate arc flash protection. This will help to protect you from the serious hazards of arc flash. In conclusion, electrical safety is paramount. Always adhere to the NEC guidelines, use appropriate safety equipment, and maintain a focus on safe work practices. Understanding the code and its applications is key to ensuring a safe and compliant electrical installation.